Algebra 1. Here we are. Going to do it a little bit different this time, so I can kind of keep it a little bit more focused, easier to set up. So today's lesson is going to be on special products. In your textbook, it's found Chapter 6, Section 9. The exercises begin on page 245. So if you wish to go to the text and study their examples, which I recommend, go a couple of pages before 245 and you'll read about those. All right. So the first thing we're going to learn about is something called the square of a binomial, or binomial square. A binomial, I want you to recall, is a sum or difference of two items. And a square of a binomial, then, we have to have the entire binomial, and then we raise it to the power 2 to square it. Okay? So to square a binomial means to take something times itself, in this case the binomial times itself. And so I have a plus b to the second power is equal to a plus b times a plus b. By way of the distributive property, we have a times a, which is written here, equals a times a, then plus a times b, because that's a positive times a positive. So we're going to have addition here. A times b is plus ab. And now a is through distributing, and now b distributes. So we have b times a, and that's written right here as, I did b times a, that's here, b times a, and then b times b, that's plus b times b. Again, a times a times b times a, and then b times b. Now we know by commutative property that a times b is equal to b times a. So on the next step, we're going to rename these four. A times a is a squared. Since ab equals ba, we can say ab plus ab, which gives me plus 2ab. And then b times b is b squared. So we want to be able to go from here to here, because the distributive property simply shows us that this is what we're going to end up with if we're squaring a binomial. That's what we're going to end up with. So the words to say to yourself to remember what to do when you see this, to be able to immediately write this down, is to say square, double product, square. Here's the square. Double means times 2, product is to multiply, and then square. So if I have a binomial square, I think first thing squared, multiply the two things and then double it, and then square. And it's that simple. So here comes some examples. To square x plus 2, we say x plus 2 quantity squared. So we're going to do square, double, product, square. Square the first term, so we're squaring x. Double is immediately multiplying by 2. Everything's positive, so we got a plus sign again. 2 times, then the product of x and 2, x times 2. And then square, so then we square 2. So this gives me x squared. The commutative property allows me to do 2 times 2, so that's plus 4x, and then 2 squared is 4. Next example, we have x minus 3 squared, x minus 3 squared. So we go square, double product, square. Notice the product is found by x times negative 3. Since that's going to be a positive times a negative, I already know the next term is going to have a subtraction sign in front of it to tell me that that product is negative. So I went ahead in this case and started with the minus sign. But to emphasize that I'm thinking of 3 as a negative 3, I've got it wrapped in parentheses here at the end before I go to square it, because I've got to make sure that a negative times a negative turns out positive. So equals x squared, negative 2 times 3 is negative 6, and then there's x. And negative 3 squared is negative 3 times negative 3, which is positive 9. Now we're going to up the game a little bit, and we're going to square 2x plus 5. So we square the first, double product, so the product is of these two items, double is times 2, and then square. Power of a product, you have to square the 2 and the x. So square 2, you get 4. Square x, you get x squared. So squaring 2x is 4x squared. The double product, we've got to do 2 times 2x times 5. Well, 2 times 2 is 4. 4 times 5 is 20. And we end it with the x. So 2 times 2x times 5 is 20x. And it's all positive. Finally, we have 5 squared. And 5 squared is 25. Because everything was positive, the final trinomial is positive. And then, I thought I'd get a little fancy. We're going to square the binomial 1/2 x minus 6. So we square the first. We're going to square half x. This time, I let the negative 6 stay on the 6. So I started here with a plus sign. And it's not going to come out any different than this example up here did. It's just when I put the negative in. So double product. The product is of 1/2 x and negative 6 in this case. Since I waited on the negative, I treat the 6 as a negative 6. So I've got double product. And then I square. Again, I make sure the negative 6 is in parentheses. Power of a product, I have to square 1/2 and x. 1/2 squared is not 1. 1/2 squared is 1/2 times 1/2, which is 1/4. Then square x. So I have 1/4 x squared. The 2 times 1/2, well, that gives me 1. 1x times negative 6, that gives me negative 6x. So there's that minus sign. And I square negative 6, I get 36. So for this squaring a binomial, the problems that are both on Gradebook Wizard and now appearing here on YouTube are to do page 245. And for squaring binomial, that will be problems 4 through 7 and 10 through 18 all. Those problems, along with the next ones I'm going to show you, all together are due next Monday, not tomorrow, but Monday a week, April 27th, 2020. The second part of this lesson concerns what we call the product of a sum as well as product of a difference. So it's actually one formula, but one time it's applied to a sum and another time it's applied to a difference. So it's also known as difference of squares. That's how I like to prefer it, but the book calls it product of sum and difference. The result is a difference of squares, and you'll see why as we walk through a couple of these examples. So first of all, the formula. We see a plus b times a minus b. And again, by the distributive property, that will be a times a, shown right here. And then a times negative b. Well, that would be negative a times b, because a positive times a negative is a negative. A is through. Now b distributes. B times a plus b times a. Then a positive times a negative. That gives me a negative. And then b times b, shown right here. Notice the interior two terms, negative ab plus ba, are actually opposites because a times b equals b times a. So when I have negative ab plus ab, that's 0. That goes away. A times a is a squared minus b times b is b squared. That's why they call it a difference of squares. Notice again, the goal is to see whether or not we have this pattern, and if we do, immediately just do a difference of two squares at the end, not having to go through the distributive property every time. Here are some examples. Taking x plus 2 times x minus 2, we notice they're the same two things. That's the sum. That's the difference of the same things. So we know we're entitled to apply the difference of squares pattern. So we square the first term x. We square the second term 2 with a minus between them. Because one was a sum, the other was a difference. The final product is a difference of two squares. X squared, we leave x squared. 2 squared is 4. So the final result is x squared minus 4. It's good to begin with that you show this interior step because there's not many steps with this at all. We're just not having to do the actual distribution. Let's go to another problem. 2x plus 3 times 2x minus 3. We have a 2x and a 2x, a 3 and a 3. One's a sum, one's a difference. So we know the result is a difference of two squares. Make sure you put the things inside parentheses or you might not get the correct squares. To square 2x, we do power of a product. So we square the 2 and get 4. We square the x and get x squared. So square of 2x is 4x squared. And then we square 3 and get 9. So the final result of 2x plus 3 times 2x minus 3 is equal to 4x squared minus 9. And now to get a little fancy, we have a difference of squares result because we have a sum, which is 3xy plus 1 multiplying 3x minus 1. What happened to my light? Hold 1. So I have 3x plus 1 multiplying 3x minus 1. So the same two objects, 3xy, a 1 and a 1. One's a sum, one's a difference. So I know I can immediately come over and do a square of the first minus square of the second, difference of squares. Now 1 square is going to be easy. That's going to be 1. This is a fancy power of a product. We have 3 factors here. We have 3 times x times 1. 3 times x times y. So we have to square all 3 factors. So we square the 3, we square the x, and we square the y. 3 squared is 9. X squared, y squared, then minus 1. So for these problems, again from page 245, where you'll use this pattern is on numbers 8 and 9 and 22 through 26 all. And again, these problems along with the previous ones are due on Monday, April 27th, 2020. See you in Zoom this week. Have a good rest of the weekend.